Hello students, welcome to channel Maths Mint by Kamlesh. It is a question for class 11 Maths exercise 4.1. Question number 4 from NCERT book. Chapter is Mathematical Induction. Question 4 is prove the following by using the principle of mathematical induction for all number belongs to natural number n. Right? Question is 1.2.3 plus 2.3.4 plus 3.4.5 and so on. N into n plus 1 into n plus 2 will be equal to n plus 1 n plus 2 into 1 plus 3 by 4. In this chapter, there are 24 questions and all questions will be solved on the same pattern, and each question has 4 steps to solve. Before this question, we have already solved question 1, 2 and 3, in which you have learnt about the different steps how this question should be solved. Only in the fourth step, the simplification will be different, otherwise everything will be same. Right? Now see how we are solving this question. Step 1 is let given equation is P of n, P of n will be 1.2.3 plus 1.2.3.4 plus 3.4.5, like this, which is the statement we are writing for Pn dot dot plus n plus 1 into n plus 2 will be equal to n plus 1 into n plus 2 into n plus 3 by 4. In first step, we shall write the statement in the form of Pn. And now in second step, step 2, if n equal to 1, we get, if n number of mathematical induction number of term is 1, so it is 1.2.3, we get LHS will be number 1 term is 1.2.3, means 1 into 2 into 3, it will be 6, and RHS will be this one, n plus 1 and so on. So RHS will be at the place of n, we shall write 1 into 1 plus 1 into 1 plus 2 into 1 plus 3 by 4. So this one multiplying any number, the number will remain same, so this will have no any value. Now 1 plus 1 equal to 2 into 1 plus 2 equal to 3 into 1 plus 3 is equal to 4 divided by 4. This 4 will be cancelled. So 2 into 3 will be 6. So LHS is also 6 and RHS is also 6. So we shall write, since LHS equal to RHS, so P of n is true for n is equal to 1. This is second step. Every step will be same for all the question of this exercise. You should know the different steps and what you will have to write and how it should be completed, because every step has separate marking system to students by CBSE. Okay. Now step 3 is let P of k be, P of k means k is for any integer. Suppose it is first term, second term, fifth term. Suppose I will prove it by fifth term. Someone can prove by taking at seventh term. So k will be any integers. Pk be true for some positive integer k, right? So now at the place of n we shall write k. So pk will be 1.2.3 plus 2.3.4 plus 3.4.5 plus, now it is n plus n plus 1, n plus 2. So at the place of n we shall write k, k plus 1, k plus 2 will be equal to this, all n will be converted into k. So k into k plus 1, k plus 2, k plus 3 by 4, right? This I shall treat as equation 1, because as we have seen in the earlier question, this third steps equation is applied in fourth step. So now fourth step is step 4. Step 4 is, now we will prove that p k plus 1 is also true. This is for k, and now k plus 1 is also true. So at the place of n we shall write k plus 1. So p k plus 1 will be 1.2.3 plus 2.3.4 plus 3.4.5 plus so on, plus now it will be k for this, k plus 1, k plus 1 plus 1 into k plus 1 plus 2. This is k. So this is k plus 1, k plus 1, k1 plus 1, k plus 2 means k1 plus 2, right? That will be equal to this. So this will be k plus 1 into k plus 1 plus 1, k plus 1 plus 1 into k plus 1 plus 2 and k plus 1 plus 3 by 4, right? Now we see that this k plus 1, k plus 1 plus 1, this is k plus 1. In the previous terms, what we see, this 1 is 1 less than 2, this 2 is 1 less than 3, so this will be also, k1 will be less by 1, so it will be k plus 1, k plus 2, right? Because it is k plus 1, so it is k, it is k plus 2, so it is k plus 1, it is k plus 3, so it is k plus 2. If you are not able to think about this, we can directly put this k of the third step, k plus last term we shall put here. Okay, so now it will be 1.2 3 plus 2.3 plus dot 4 plus 3.4.5, and this will be plus k plus 1, k plus 2, and this will be k plus 1, this will be k plus 2, and this will be k plus 3 will be equal to k plus 1 into k plus 2 k plus 3 into k plus 4 by 4. Okay, this is k plus 1, this is k plus 2, this is k plus 3, this is k plus 4, and this we have already written k plus 1, k plus 2, and this k plus 1, k plus 1 1 2, k plus 1 plus 2 3. Now we see that up to here, okay, it is equal to k plus 1 plus k plus 2 plus k plus 3 in step 3. K plus 1, k plus 2, so it is k plus 1, k plus 2, it is equal to this. So up to here we shall write by equation 1. Here we shall also write by equation 1. Up to this we can write equal to this. So it will be k plus 1, k plus 2, k plus 3 by 4 up to here, and this will again repeat. So plus k plus 1, k plus 2, k plus 1, k plus 2, k plus 3 will be equal to k plus 1, k plus 2, k plus 3, k plus 4 by 4. So this became LHS, this part and this part became RHS. Now we shall solve LHS to make it equal to RHS. So LHS equal to this one. What we see here, k plus 1, k plus 2, k plus 3 is also in this term, k plus 1, k plus 2, k plus 3 is also in this term. So this we shall take common. So k plus 1, k plus 2, k plus 3 I have taken common. So what happened? This k is left here, k by 4, k and by 4, and this become 1. Now k plus 1, k plus 2, k plus 3, and it will be 4 will be LCM, so it will be k here, 4 divided, here we shall take 1 dividing to 4 and 1 plus 4. So it will be k plus 1, k plus 2, k plus 3, and it will be k plus 4, and this 4 is dividing. So this became RHS. K plus 1, k plus 2, k plus 3, k plus 4, k plus 1, k plus 2, k plus 3, k plus 4 divided by 4 is equal to RHS. Right? Here LHS equal to RHS. So P k plus 1 is also true whenever P k is true. This line we have to write in the last, these things in every question. Hence, by principles of mathematical induction is true for all natural numbers. Right? So this is our answer. I hope you will please like, share and subscribe this channel. If you have any doubt, please write in the comment box. I will answer it. Thanks.